Hello everybody, welcome once again. And from the last two tutorials, as you remember, we have shown you using the dSPACE control system how to send a certain signal to a certain device and how to receive some certain signal from some certain device. And currently what we're going to do is in the third tutorial we're going to show that using the knowledge from those previous two tutorials, how you can apply those knowledge onto the real life plant we have. And in order to do that, what we are doing is we're going to basically show how you can send some signals to some certain device here and run it, and at the same time how you can receive and read some signals from the sensors we have. And in order to do that, we are sending the signals to the pumps we have, because it is not possible to run the whole system into this one tutorial. What we are doing is we are sending a signal only to the pump, and we are going to run this pump in a certain direction and a certain speed. And later on, in case of receiving the signal, what we are doing is we are receiving signals from the ultrasonic sensor we have, and seeing the level of the water, because as if the level of the water changes, the signal output from the ultrasonic sensor will be changed as well. So these two we are currently going to do into this third tutorial. So let's start from moving the pump, and in order to do that, here we have already designed a Simulink model. As you remember, you need to design the Simulink model at first. So this is the Simulink model. Let me just explain the model a bit to you. For the pump we have, there are two parameters which are needed to move the pump. One is the speed of the pump, and another one is the direction of the pump. In order to move the pump into a certain direction, what you need is basically a step pulse of 0 to 5 volt. Whenever it is 0 volt, it will be moving in a clockwise direction, and whenever it's a 5 volt pulse, it will be moving in an anti-clockwise direction. And in case of the speed, it starts from the 0 volt, and if you just keep increasing the voltage from 0 to 10, when the 10 volt is transmitted to the pump, it will rotate in the highest direction, in the highest speed, which is the 220 revolution per minute. So in order to do that, we are sending two signals. You can see one is for speed and one is for direction. And for the direction, we have set the constant as 5, and for the speed we are going to make it as 10 for the time being. We're just setting up the constant, and as you can remember why this gain is used. So this is one new thing we need to basically learn about. This is a multiplexer. What it does is basically it is going to take both the signals together, and it is going to flow it into the same stream we have, because we have got only one stream which will go inside the DAC board that we need. And after adding this multiplexer here, what we're doing is we're basically sending the signal to the DAC board. And into the DAC board, as before, what we are doing is we are assigning the channels. Here we are assigning the channels as channel number 9 and channel number 10, and we are saying OK. And this model has already been saved, and in order to generate the SDF file for determining the algorithm and sending it to the dSPACE control desk, the graphical user interface for control desk system, the dSPACE system, we will have to build it. And in order to build that, we are going to press Ctrl and B together, and the building process has started. C files are generating and disconnecting to the bus, and meanwhile we have already turned on the dSPACE system as well, so it's loading the application. We can see the SDF file is here and it is successful already. That's good. So we have successfully generated the SDF file, which is called transmit_test.sdf. Now what we are doing is we are going to open the dSPACE control desk in order to send two signals. It's taking a while. So firstly, what we'll have to take care of is if any of the cores are working, we'll have to make it stop. So we are stopping it. Now we are going to make a new project and experiment. Let's make it as motor underscore tutor. Say next. Experiment number 1 is fine. Experiment number this page is fine as well. Go next. And now we are importing the SDF file, and that name was transmit. So let's go to T. So this is the SDF file we need. So we are going to open it here. The SDF file is imported and we are saying finish. So now from the previous experiment, as you can remember, we'll basically have to select some of these instruments in order to send the signal. So as we are basically sending two of the signals now, we are taking one slider for the speed, so that you can basically slide the bar here and see how the speeds are changing. So we are taking the slider for speed, and we are going to take a numeric input for the pulse, which is going to be used for changing the direction. So what we are doing is we are just going to change a bit of instrument properties by right clicking on it, and we are going to make the increment as we need. We are going to make the increment as 0 and 5, so that it will change from 0 to 5 straight away, as because we are sending either 0 or 5 in order to change the direction. So it is saved, and for this we are changing the properties as well a bit, and we are making 0 to 10, as because for the speed we need, speed of the pump, we need 10 volts to the highest, and this is it. And now it comes to the linking part. We are going to link the two constants that we are sending with the instruments we have. So constant number 1, let me take a look into the main model here. So the constant is the direction, for the direction, and constant 1 is for the speed. So that's what we are doing. Constant is for the direction and constant 1 is for the speed. So they are both connected. For the last time, we're again going to take a look if any of the cores are working. These are all fine. Now we're going to calibrate the system and see. Let's calibrate it. Great. So it has been already calibrated. Now we are connecting it with the real life system. Let's get back to the pump we have. If we take a look into the pump here, so this is the pump we are using, and you can feed the pump expected signals through this wire, as you can see, this where it basically comes out of the pump here. So if you just follow this wire here, you can see it has got a level over here which says which are the wires for speed and which are the wires for direction. And we see the orange and black plus pink is for the speed, and the pink and black and yellow is for the direction. So pink and black and yellow for the direction, and the other one is for the speed. So if we just figure out, what we will see is this one is for the direction and this one is for the speed. As we have assigned some channels inside the Simulink model over there, the number of those channels were channel number 9 and channel number 2. This is why these channels are already connected here in order to run the pump. So the directional one and the speed one has been connected to the channel number 9 and channel number 2 in order to run the pump. So as we have already connected the channels with the pump, now for the last time we are again taking a look here. So this is our model, this is the algorithm by following this is the algorithm which is going to be followed by the dSPACE system, and the DAC control panel here. Let me just show you. It is channel number 9 and channel number 10, not channel number 9 and channel number 2. Sorry for that information before. So we have rightly connected with connected with channel number 9 and channel number 10 here, not channel number 2 again. Now what we're doing is we are going to turn on the whole system here. So in order to turn on the system, you just have to turn it on, and the whole system is now turned on. And as you can see, this pump is turned on as well. What we'll have to do is we'll have to just because this pump can run in auto mode and manual mode as well. So currently we are doing it in auto mode, so we'll basically have to change the mode from the control panel over here. We have changed the mode to the automatic mode, so it has been changed. All we'll have to do is to start and it will start moving. So let's start it here. So it is now moving, as you can see. Now what we are going to do is we are going to get back to the dSPACE control desk. We are going to change the parameters over there and see, while we are changing the parameter, the characteristic of the pump, is it changing or not. Let's get to the dSPACE system. Now what we are doing is, we can see it is 5. That is the reason it is moving into an anti-clockwise direction, and it is set as 10 over here. That is why it is moving into an RPM of 220. So what we are doing is we are going to decrease the speed a bit. So I believe you can hear the sound. It is basically decreasing. Let's take a look. So the speed has been decreased, as you can see. Let's see if we change the direction, does it really change or not. Get back to the dSPACE system again. Now we are changing it to 0. Let's take a look if the direction is changed. Now as you can see, this is moving into a clockwise direction now. The direction has been changed as well. And into a clockwise direction, if you want to increase the speed, you can do the same by increasing the voltage here from 5 to 10. So into a clockwise direction, it is changing the speed. So as you have seen how to send a signal to the pump and how to run the pump in a particular direction and speed. Now what we are going to do is, as I've already mentioned, we are going to receive some signal from the ultrasonic sensor we have. We have got 3 ultrasonic sensors here, but we are basically dealing with the ultrasonic sensor number 1 over here, which is called ultrasonic level detector 1. And in order to do that, we'll just have to know a bit insight about the device itself. For this ultrasonic sensor, this is basically a level detector, so this will detect the level of the water here. And what we will have to do is we will just have to know using which wire does the output voltages come. So in order to know that, we'll have to look at the documentation. Basically, before showing the documentation, let me show you the wiring inside. So this is the wiring inside. So you can see the wiring inside is like this. And now let's take a look at the documentation a bit. So the documentation from of the ultrasonic sensor we can see the white wire that comes out of the sensor is for the voltage out. So that is the only wire that we will have to take care about. And the number of the white wire that comes out of the sensor is 97 over here. As we can see, it is 97. It is 97 over here. So now what we do is we take a look into the whole circuitry design that we have, that has been provided with the whole plant, which is this. So we will now have to find out 97 from here, which is this, and it is written level number 1, which is for the level detector 1, and it is connected with X84. Now this X84, what it is if we just take a look here, this is the X84, and it is connected to the instrumentation panel over there. You can see this is the instrumentation panel we have, and this X84, it has gone inside the instrumentation panel, and the other side of this X84 wire, it has come to the ultrasonic sensor that we're working with. So basically this has a connection with the ultrasonic sensor, and this is detecting the voltage which is coming out of the ultrasonic sensor as the level is changing. So this connector number 84, it is connected to the AD board. Why it is connected to the AD board, I believe you understand already, because we are receiving the signal instead of transmitting it this time. So that is the reason we have connected this X84 wire to the AD board here. Now let's get to the design. In order to receive signal, the design is pretty simple because we are only receiving one signal. That is the reason we are using only one scope over here. As you can remember from the tutorial number 2, we have, in order to receive a signal, all we need is basically to set up the ADC board into Simulink and use a gain of 10. I believe you remembered the reason, and use the scope. So this is the scope that we are using here, and let's see what is the channel assigned here. The channel assigned here is number 25, but we have connected it to number 1, so we are changing the channel to number 1 and saving it. So this is where we are saving it, and we are going to generate the SDF file by building it by pressing Ctrl and B together, and it will start building, and it has started building already. So model is building. We are waiting for the SDF file to be generated. Once the SDF file is generated, we will import that SDF file to the dSPACE control desk in order to give the dSPACE system the algorithm what it needs to receive signal from the sensor we are using. So it is successful. We have got now the SDF file called receive_test.sdf. So let's get back to the control desk. So the control desk is here. Great, let's take a look if any of the cores are working. Yes, one core is already working. Let's stop it. This is stopped, and now we are going to open a new project and experiment. Let's save the sensor underscore test. So we are testing the sensor. Say next, experiment number 1, say next again, and import the SDF file from here, and the name was receive_test. So we are going to R, and this is the SDF file we need, and we are opening it. It has been imported already, and we are saying finish. And in order to scope the signal, in order to see the signal which is coming out of the sensor, we can either use the bar, or you can use gauge or plot or something like that. Let's use a bar here. So this is the bar we are using. Let's change it a bit. Let's make it 0 to 1, sorry, 0 to 10. There we go. So it has been changed to 0 to 10, the properties, and now we are going to connect the Simulink blocks with the equipment. The appropriate Simulink block is scope. As you can remember, in order to read a signal, you need the scope to be connected with the equipment here. That is what we are doing, dragging and dropping it on the equipment, and again taking a look if anything is assigned. Nothing, so we are calibrating it now. So it has been calibrated already, and we are not seeing any signal over here because the plant is turned off. We will have to turn on the plant again. Let's get back to the plant. There we go. This has been turned on now. How we know it is turned on is coming here and seeing this is sending a signal of 8.9 or 9 volt, near about 9 volt. This is sending. Now let's see, once we are changing the level of the water, as because we don't have water, we are going to use our hand as the level for the level determination. So we are changing it from here. If you can take a look over there as well, from that, once I am raising my hand, the voltage sent to the system is decreasing. As you can see, it is decreasing. The nearer it is getting to the sensor,
the less signal we are getting. So when it is very near, it's almost 0, and when I'm touching the sensor, it is completely 0, and vice versa. Whenever the distance is increasing, we are getting more signal, more and more signal over there, and so on and so forth. So this is basically how we can see the signals are received from a real life sensor inside the dSPACE. So other than using the block we are using here, this is the bar we are using. We can use gauge so that we can see the plotter which is going back and forth in order to mention what signal is coming in. So this is like simply demonstrating how the signals are being received from a particular sensor. So this is it, I believe, and we will meet you again in some next tutorial later on. Thank you very much.